We now discuss the solution of the problem from the section Differential Calculus, and the problem is on the number of discontinuities of a given function. This question has appeared in the joint entrance examination main held on 24th June 2022 in the first session. The problem is the number of points where the function f of x, defined in this way in a piecewise manner, is discontinuous is. We have to find the number of points where this function is discontinuous is. So that means the function f of x is given to be mod of 2x square minus 3x minus 7 if x less than or equal to minus 1, bracket 4x square minus 1 if minus 1 less than x less than 1, mod of x plus 1 plus mod of x minus 2 if x greater than or equal to 1. And this is the function given to us. In this, there is this bracket function, that is the greatest integer function, is also appearing. So where bracket t denotes the greatest integer less than or equal to t. So we have to find the number of points of this function where it is discontinuous. So that is to be discussed. We now discuss the solution of the problem in detail. And the given problem, the given function is defined in a piecewise manner in 3 steps. And this is your first step. That is case 1 we take. We have fx is equal to mod of 2x square minus 3x minus 7 if x less than or equal to minus 1. And let us take g of x to be equal to 2x square minus 3x minus 7. Note that this is a polynomial, and we know that every polynomial is continuous everywhere on the real numbered line. So notice that g of x is 2x square minus 3x minus 7, and it is continuous everywhere on the whole of the real number line, and because it is a polynomial. And it represents a parabola opening upwards, and it is continuous. We have already seen in our earlier classes. Now, therefore, g of x is that is 2x square minus 3x minus 7 is continuous in the interval minus infinity to minus 1, where minus 1 side is closed. And why? Because it is continuous everywhere, therefore it is continuous in this interval. So now f of x is equal to mod of g of x, that is mod of 2x square minus 3x minus 7, is also continuous in this interval minus infinity to minus 1. Why? Because gx is continuous. When gx is continuous, mod of gx is also a continuous function. This is also a result what we know. So therefore f of x is equal to mod of 2x square minus 3x minus 7 has no discontinuities in minus infinity to minus 1 because it is continuous in this. But note down f of minus 1, so that means put x is equal to minus 1 in this, we will get 2. And this is required when we go for the discussion of continuities and discontinuities on the whole. Let's get into the second case, where we have f of x is equal to mod of fx of mod of 4x square minus 1 if minus 1 less than x less than 1. And we have a result, and it is a result on greatest integer function, and this is bracket of greatest integer of x plus n, where n is any integer, is bracket x plus n. So bracket of x plus n is equal to bracket x plus n, where n is any integer. So here n is minus 1, so therefore this can be This is equal to bracket 4x square minus 1 if minus 1 less than x less than 1. So we ask a question. For what values of x belongs to this open interval minus 1 to plus 1, y is equal to 4x square is an integer. First we see y is equal to 4x square will give you 3 for x is equal to plus or minus root 3 by 2 that belongs to the open interval minus 1 to plus 1. And y is equal to 4x square will give you the integer 2. It always gives you positive integer for x is equal to plus or minus 1 by root 2 that belongs to the open interval minus 1 to plus 1. And y is equal to 4x square will be 1 for x is equal to plus or minus 1 by 2 that belongs to the open interval minus 1 to plus 1. And y is equal to 4x square is equal to 0 for x is equal to 0 that belongs to this. Of course, this is not required. This is up to this is sufficient. And note that minus 1 less than minus root 3 by 2 less than minus 1 by root 2 less than minus 1 by 2 less than 1 by 2 less than plus 1 by root 2 less than root 3 by 2 less than 1. So this is the one. And the subintervals the subintervals minus 1 to minus root 3 by 2 and so on and so forth can be considered in the next slide. Now we have already seen the minus 1 less than minus root 3 by 2 less than etc. in the last slide. Now fx is equal to bracket 4x square minus 1 will be bracket 4x square is 3 minus 1 that will be 2 in this interval minus 1 to minus root 3 by 2. So in that the greatest integer that is for bracket 4x square is 3 which we have already seen. So this is the one. So 4x f of x is equal to bracket 4x square minus 1 and in this interval it is 2 minus 1 1. Now f of x is equal to bracket 4x square minus 1 is equal to 1 minus 1. So in this interval this is 1 and this is minus 1. So this will be 0. So f of x is equal to bracket 4x square minus 1 is equal to in this interval bracket 4x square is 0 minus 1 and that is the minus 1. So f of x is equal to 4x square and minus 1 will be equal to it will 1 and minus 1 in this interval 1 by 2 less than or equal to x less than 1 by root 2. So and in this interval this is 2 minus 1 1 and f of x is equal to bracket 4x square minus 1 that will give you 3 minus 1 in this interval it will give you 3 minus 1 that is equal to 2. So notice that there are jumps in the values of fx at x is equal to minus root 3 by 2. So at minus root 3 by 2 plus root 3 by 2 minus root 3 by 2 here and there is a jump 2 to 1. So this is 2 to 1. So at x is equal to minus root 3 by 2 it jumps. So the left hand continuity if you see this will be 2. The right hand limit is 1. They are not equal, therefore it is discontinuous there. And jumps means jump discontinuity that is there. That means they want both the sides that is left hand limit right hand limit exist but they are not equal. Next x is equal to minus 1 by root 2 there is a jump from 1 to 0. So and 2 at x is equal to minus 1 by 2 there is a jump 0 to 1 0 to minus 1 and fourth one x is equal to 1 by 2 the jump is minus 1 to 0. Fifth one x is equal to 1 by root 2 there is a jump 0 to 1. So sixth one, x is equal to root 3 by 2. There is a jump from 1 to 2. So in all, there are 6 jumps what we have noticed. That means there are 6 discontinuities for this function in the interval -1 to +1. So f of x has 6 jump discontinuities at the above points. Now we continue in the next slide. And this time f of x is equal to mod of x plus 1 plus mod of x minus 2 if x greater than or equal to 1. This can be broken now. This is equal to if 1 less than or equal to x less than 2, when x less than 2, x minus 2 will be negative, mod of x minus 2 will be minus of x minus 2. When x greater than or equal to 2, x minus 2 is greater than or equal to 0. Therefore, mod of that is x minus 2 only. So when simplified, this will give you 3. If 1 less than or equal to x less than 2 and 2x minus 1, that is x plus x minus 1. 2x minus 1 if x greater than or equal to 2. Now, this is a continuous function from the 1 to infinity, closed at one end. And if at all there is a discontinuity, if someone suspects, then the left hand limit at 2 is 3, and at the right hand limit it is 2 2s are 4 minus 1 3, so they are equal. So the right hand limit, left hand limit is equal at x is equal to 2. Therefore, it is continuous from 1 to infinity. So therefore, clearly f of x is continuous in the 1 to infinity closed at one end. Agreed. We now consolidate our situation. So we have mod of 2x square minus 3x minus 7 if x less than or equal to minus 1. We have already seen it is continuous in the interval minus infinity to minus 1 closed at minus 1 end, and we have seen the value f of minus 1 is 2. So now let's get into the second branch, that is f of x is equal to bracket of 4x square minus 1 if minus 1 less than x less than 1, and note that f of x is equal to 2 in the interval minus 1 less than x less than or equal to minus root 3 by 2. So this is a left hand limit at minus 1 is 2, and the right hand limit at x is equal to minus 1 it is 2, so it is continuous there. So it is 2 here, 2 here, and that will tell you the left hand limit, and this will tell you the right hand limit, and they are equal. Therefore, it is continuous there. So therefore, that curve connecting this one up to this one up to in this interval will be continuous. Therefore, f of x is continuous at x is equal to minus 1. But we know f of x has 6 discontinuities in the open interval minus 1 to plus 1. And we have already noted f of x is equal to 2 in this interval root 3 by 2 less than or equal to x less than 1. Let's get into the third branch. We have f of x is equal to this if x greater than or equal to 1. And we have seen it is continuous in the interval 1 to infinity and closed at one end. And we have already seen f of 1 value is 3. Now what we see is this 2. So that is x at 1 limit the left hand limit at x is equal to 1 is 2, and the right hand limit at x is equal to 1 is 3. They are not equal, therefore there is a jump discontinuity at x is equal to 1. So now it shows f of x is discontinuous at x is equal to 1. So in all, so there are 6 discontinuities, and this is one more discontinuity. Therefore, in all, there are 7 discontinuities are there. Therefore, the number of discontinuities of f of x is 7. Our answer is 7. It is definitely an interesting question, but it may be a little bit difficult in the examination hall to visualize all these things. However, once in a while, such type of questions do come in the examination. So I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.